To price an option using a binomial model, I prepared a special function using Python programming language in order to calculate price for call and put American options. So let's look at this.
Now I will show you estimation of an American put option value with the help of binomial model, which was constructed using Python programming language. So let's look at our example. I decided to take an option for a stock Aeroflot, which expires at September. So let's put our code in work. And here, as you can see, we have our binomial tree for an asset, which is in the form of a diagonal triangle matrix, downside. And upper, we have another matrix with prices for an American put option. As we can see here, this is the estimation with the binomial model of a value of American put option to the current day.
To calculate the price of an American option using a binomial model, we need several variables. So let's look at them. First of all, we need a spot price, which is the initial price of a stock or an asset for which we want to calculate a price of an American option. The second is K. It indicates the strike price of an option. Sigma, which indicates the volatility. R, risk-free return rate. T, time to maturity. In my function, it is measured in years, and I recommend to measure it in years. And a dummy variable, which takes 1 or -1, depending on the option we want to calculate. It takes 1 if we want to calculate a price for a call option, and -1 for a put option. And also, I realized the second dummy variable, American, indicating if we want to calculate the price for American or European option. It takes true if we want to calculate for American option and false for European. To start constructing our binomial tree, we need to calculate several variables. First of all, delta, which indicates the size of the step in our binomial tree. Also, we need to calculate upside and downside movement of the stock price. In my example, these variables are called U and D. And create matrices of the size n+1 and n+1, where we will put our price of the option and the stock. Also, we need to calculate the probability of the upside and downside movement. Actually, I'm calculating only probability for the upside movement, which indicates Q. Each subsequent element of the zero column equals to the spot price multiplied by D. If you remember, D is the coefficient of the downside movement of the stock price. Here we calculate n+1 numbers, and the final is S multiplied by n D power n. Now we are ready to fill other elements of our diagonal downside triangle matrix. Each element with coordinates E and G is calculated as multiplication of the element E-1 and G-1, so the upper left element. For example, I will take the element with coordinates 1 and 1 and try to calculate it. It will be equal to the spot price multiplied by U. Each subsequent element is calculated according to this formula. So, element with coordinates E and G equals to multiplication of the element S with coordinates E-1 and G-1 multiplied by U. For example, the element with coordinates n+1 and n+1 will be equal to the maximum possible movement of our stock price. It will be equal to S multiplied by U power n. If you will fill this matrix according to this algorithm, you will obtain a binomial tree, which you can construct in any other program, but it will be in the form of a diagonal downside matrix. Now we are ready to construct a binomial tree for our option using the same algorithm. So, if you remember, we also formed an empty matrix with the size of number of step plus 1 on number of step plus 1. Depending on the type of an option we want to calculate, whether put or call option, for calculation of the price on the last line with coordinates g equal to n plus 1, we need to subtract from the stock price the strike, or whether from the strike the stock price if we want to calculate the price for American option. I want to emphasize that we need to calculate the maximum between two variables. Between the subtraction of k minus s, or whether spot price minus strike, and 0. This we will use to calculate the price of an option for the last line in our matrix. Now we are ready to fill our downside triangle matrix in order to obtain a binomial tree for our option and calculate the final price using the binomial model. So let's look how to fill this matrix. I will explain its filling on the example of a point which has the coordinates E and G. I want to emphasize that G may have any coordinates depending on the line we want to fill, so it actually can take the value between 0 and n plus 1. And E should not be more than the coordinate of a downside right point with the coordinates E plus 1 and G plus 1. So let's look at the example how to calculate the price for an option at this point. We also will need to obtain the prices of an option for the points E plus 1 and G plus 1 and E and G plus 1. So here are our 2 points. If you remember, in the step of calculation and obtaining the matrix for the binomial tree for a stock price, we calculated the downside and upside movement of a stock price. Here we will calculate the weighted probabilistic movement of an option price using actually the same formula. So the option price at the point with coordinates E and G will be equal to the maximum. We calculate the maximum because we are obtaining the price for an American option. If we want to obtain the price only for the option European, of the European class, we can obtain just the weighted probabilistic discounted movement of one option price. So here is the formula. The first one, we are calculating the probabilistic price. I call it probabilistic price because we use the upside and downside movement and probabilities of this. So P is the probability for the upside movement multiplied by the option price in the point. If you remember, we calculated all the upside movements. They are lying on the right side of the matrix. Actually, you can calculate it with another example. For example, here you may obtain only the upside movements, and on the right hand there would be the downside movements. Actually, there is no, these steps are similar. So here I am writing the formula for calculation of option price with in the point with coordinates E and G. So if you remember, we need to find the maximum between the two variables. The subtraction of, let's for example take a price for a put option. For call, actually everything will be with the coefficient -1, so we just will need only to multiply our results with this coefficient. So we need to calculate the subtraction between strike price and spot price in the particular point, in this point, with coordinates E and G. So we'll subtract the price from K the spot price with in the point with coordinates E and G. And we should compare it. Так. Здесь, в принципе, можно здесь будет, наверное, обрезать просто. And we should compare it with the price of an option calculated as a weighted probabilistic movement. P is the upside movement. I will indicate it like that. If you remember, all upside movements are lying on the right side. For example, if we will develop our algorithm with the calculation, with here we will use upside movements, all the downside movements will be on the left. So we will, but in our example, we should multiply it by option price in the point with coordinates E plus 1 and G plus 1. And then we should calculate actually the mathematical expectation of this movement, so we should summarize the downside movement and it's multiplied by its probability. So I will show it here. So here is the price of our option if the stock moves upper, and here if the stock moves lower. Also, we should discount it by the discounted coefficient, which will look like that. We assume that we can invest any times in a year. So actually, we assume that we are living in the world with continuous rates. So we should discount it by the exponent or the number year, E, in the power of minus dt, where dt is the size of the step. If you remember the size of the step, we calculate as the time to maturity of an hour option divided by the number of steps. Here I will write the formula. And we should multiply it by the discounted rate. In my algorithm, it's R. And we should calculate the maximum between these two variables. Actually, if we will use this formula to any upper elements of our matrix, we will finally get the binomial G. As you can see, this is a recursion algorithm, so we should start from the end and move to the present time. So here, in the point 0, 0, we'll obtain the option price. And this price actually would be the result of our binomial model. So, to fill the matrix, we should move right and down, and each subsequent element should be constructed with the left upper previous one by multiplication of it by U. So we will get the matrix of a stock price, and it will be in the form of a binomial tree. The next is the option matrix. First of all, we need to calculate the price for an option for the bottom line, for the non-binomial formula, for an American option, because we calculate the price for this option. And each subsequent element should be filled by moving upper and left with the use of the previous up, with the previous down left and down element. Also, we calculated with the use of a non-binomial model formula for calculation of American option price. So this is the algorithm for filling these two matrices and we will obtain the final price for an American option, which will give us the binomial price. Let's proceed to the final difference method. For this, we need to construct a grid. This axis corresponds to time, and this axis corresponds to spot price of the underlying asset. The size of the step in time equals delta t. It equals to the step in the binomial model. And here we should calculate the ds, step of the spot price. For this we need to obtain the stock price from the binomial model when the option price equals 0. Next we should adjust it so that when we divide it by the number of steps on some of them we obtain the current value of the underlying asset. Then we add 3 columns with coefficients a, b and c, which correspond to the standard coefficients of the final difference method. Also we should add 2 working columns, v1 and v2, which contain the values of an option for some particular time period. The column v1 is filled using the solution of the system of linear equations with the help of coefficients a, b and c. And the column v2 is formed using the checking of the assumption that we can execute our American put ahead of time. We are filling this table from right to left. In the last column we obtain, opposite the current value of our underlying asset, the value for the American put. In both methods we obtain the estimated value of American put. In order to get more accuracy we should adjust it with the help of control variate method.